Hello, Math 30 dash 1. This is lesson 10, and in this lesson, the learner outcome for this is that you will be able to derive an equation of some sinusoidal function, an application, a Ferris wheel, a pendulum, some kind of application that you can take the information given and you can derive your own equation. In lesson 9, you took an equation and used your graphing calculator to find out information. Now you have to do it yourself. So to recap what we need to come up with an equation, we have this review question. So given this function, a sinusoidal wave, I need to find the equation for this graph. The best way to do that, they are referring here to, they have a maximum of 50 and a minimum of 10. This also notices sine. So when we look for equations, the first thing I want to do is I want to, oops, that's a pretty heavy line. So we'll take that off of there. Let's just keep it simpler, something like that. So when I look across, that's the midline of my graph. When I look for where sine is right there. So now, when I come up with that equation, I consider that. First thing I look at is what is the amplitude for this? Well, I'm looking for amplitude. We can use the formula that you've seen earlier. You can take the total difference, so amplitude is equal to 50 minus 10 divided by 2, which is 40 divided by 2, which is 20. Or you can look at the graph and clearly see that it goes up to 50, which is 20 above, and goes down to a minimum of 10, which is 20 below. Next thing is B. Well, when I'm going to calculate B, that's about period. I consider this graph and I can see that the period of this graph, it starts at 16 and ends at 48. So this period of this graph is equal to 24. Therefore, when I use my formula, the period is equal to 2 pi times that stretch factor of 1 over b. What does b equal? B equals, when I solve for b equals 2 pi over 24. I know I could reduce that, but I'm going to leave that. Next is C. When I consider C, I just look, where does my sine wave start? Well, there is my smallest phase shift for sine, and then it starts again. So clearly, I have a phase shift of a horizontal shift or a phase shift. Oopsie. I have a phase shift of 16 to the right. 16 seconds to the right. And lastly, when we look at D, clearly this has a vertical shift of up 30. Therefore, my equation is going to be H at T is equal to an amplitude of 20 times sine bracket 2 pi over 24 bracket T minus 16 and plus a height of 30. You have to excuse me for a little bit of bad subtraction. So you'll notice that when I went to do period, I went from 16 to 48, and I said that that was equal to 24. That was some bad subtraction. So we need to go back, and if you look right here, that total period was actually 32, not 24. From 16 to 48 is 32. So my B value is 2 pi over 32, which over here is also 2 pi over 32. And again, some textbooks are going to write that as pi over 16. So now we take what we know now and we go to our nail question in question or example number 1. Again, read the question, the context of the question, and try to come up with the equation. So again, as you start to play, notice I've made note of a few things whenever I'm given a question like this. So clearly the tire has a diameter of 50 centimeters. So I can clearly see if I draw the midline of the graph, it's going to have a peak of 50 and a low of 0. So there's an amplitude, I guess we can start seeing there's an amplitude of 25. The 10 revolutions per minute, when we start thinking about period, well, if you made 10 revolutions per minute, equivalent fraction would mean that would be, if I divide top and bottom by 10, that would be 1 revolution in 60 seconds. So that might give you a tip off at the period. It mentions that at 4.5 seconds, notice the nail will go 3/4 of the way around the tire, and at 4.5 seconds right here, at 4.5 seconds, the nail is back on the ground. Well, that makes sense because at 6 seconds, it'll be back to where it is in the middle of the tire, right? Use this information to write a scale for each axis. Well, I think we can say that this would be 25 and this will be 0 and that up at the very top would be 50. And I could make a scale and say that each of these is 1.5 and that's 3, 4.5 and that's 6. So if we're going by 1.5 seconds each critical point, that would be good. And that makes sense because if the period is equal to 6 seconds, then every critical point occurs, right? There are 4 critical points to complete a sinusoidal curve, and that means that every one of those occurs every 1.5 seconds, right? So now we're supposed to determine equation. Well, when I consider what the amplitude is, well, clearly the amplitude is equal to 25. When I consider what B should be, I know that the period is equal to 6 seconds, so 6 seconds equals 2 pi over B. Solve for B, and that means that B is equal to 2 pi over 6. Notice that we're not talking about C, and the reason is when we look at sine, there is no phase shift. So C, when we consider C, C equals 0. And lastly, D, well, D is equal to 25, and therefore we have a function of h of t is equal to 25 sine 2 pi over 6t plus 25. How far, when we consider how far to the nearest tenth of a centimeter is the nail above the ground at 6.5 seconds, what's the height? Well, if you look at the graph, clearly 6.5 seconds is somewhere right here. So it better be above 25. Otherwise, I think we probably have the wrong answer. So again, we could use the equation, or we can just use the graphing calculator. H at 6.5, you should be able to come up with an answer of exactly 37.5 centimeters above the ground. Moving on to example 2, read the information carefully and draw a graph of the data to come up with your answer. So, we are recording. So in this graph, you need to kind of read through the graph, and there's some important information there. This Ferris wheel is 76 meters in height. It has a maximum height of 80 meters. The wheel had 36 wooden cars. I'll leave that there. So as you guys graph the table of values, you will see as you plot those values that it creates a sinusoidal curve with those critical points. So if you chart the table of values, that's what you end up with. Now that you can see the picture, it becomes a lot easier to create the equation of the line by create the equation of this function by considering amplitude, phase shift, period, and vertical shift. So if you consider our imaginary axis about where this graph is and what's going on, if I draw my imaginary axis for this curve, I have to consider that this curve is speaking about cosine, as you can see right there. And if it's speaking about cosine, then the middle of the graph, as we can see here, is at 42, and the starting point for a cosine wave to Chad would be right there. So now there's also one other option that in this case you could also consider minus sine. So here's another option for where this graph starts. This graph could also be considered to start right here, and that would be if we were considering a sad sine wave. So in this one would be y equals minus cosine, and starting from the bottom and working its way up. So based on that, you need to decide what the amplitude is. So by looking at my graph and considering my axes, because I know that this Ferris wheel, if I consider amplitude, this Ferris wheel had a diameter of 78. Therefore, this, the diameter of the Ferris wheel was 76. So if it's 76 meters in diameter, divide that by 2, its amplitude is 38 meters. When I consider my B value, well, I have to consider what the period is. This Ferris wheel is completing a rotation in positive. To find the B value, We know that in this case the period is equal to 9 minutes. So therefore 9 is equal to 2 pi over b. So if we solve that, b is equal to 2 pi over 9. Considering c, well, that depends on where you start cosine. There are two options. If you start at 4.5 minutes, then that's your phase shift. So c could be 4.5 minutes to the right. That could be the phase shift. Or if you're considering negative sign, the phase shift could be equal to 0 minutes. You need to decide which one you're comfortable doing. And lastly, D, the vertical shift. This vertical shift is clearly a vertical shift of 42 meters up. Therefore, the equation for this Ferris wheel ride, the first Ferris wheel ride ever, is the height with respect to time is equal to 38 times cosine of 2 pi over 9 times t plus 42. Or if you consider the phase shift of 4.5, then your equation would be the other one. Either one would be fine. They both define the same curve. Question C asks you, how high is it after 5 minutes? You could graph it on your calculator, or you could substitute it in and use the equation. Either way, you get nearest meter. So this turns out to be 77.708 meters, which in this case is approximately equal to 78 meters to the nearest meter. How many seconds after the wheel starts rotating does the cart first reach a height of 10 meters? Well, the keywords there are first reach a height of 10 meters to the nearest second. And if you look back at your chart to give you a rough idea of where that might happen, when does it first reach a height of 10 meters? That's going to be less than, right? How many seconds after? It's going to be less than a minute, right? So we need to look and see on our calculator. We can graph it, or we could solve the equation. It turns out that h at t, for h at t to be 10, you could substitute an equation of y equals 10 in there and see where it intersects. Turns out that the first intersection point is when t is equal to 0.8159 ... seconds. So t is then approximately equal to, that's t equals 0.8159 minutes. We talked about converting that, so that would be that 0.8159 to seconds, so you'd multiply by 60, and that turns out to be 49 seconds to the nearest second.